Hello there. Today we'll be going over movie theaters, given a list of time-exclusive intervals for different movie showings, possibly overlapping. Find the minimum number of movie theaters required to be able to show all movies. So, what we're doing here in this particular problem, in example 1, that this does not give us a very clear picture about what we're trying to solve for. But what we're trying to solve for is the overlap. If there is two overlapping movie theaters, that counts as 2. Maximum of 2 overlaps, and here there's no overlap, so it's only 1, and there are an overlap of 3, so we get 3. So how do we get overlaps? One idea is to make sure that this start is less than the end, and we can add that to the add each end to the interval and keep the minimum. And if the start is greater than the end, that means we need to remove that particular end until we can add the new start in, and until we can add that new end in to collect a bigger group. So what I mean by that is, let's sort the intervals, and with that, let's create a heap, and max theaters equals 0. So for start and end in intervals, while heap and s is greater than or equal to heap 0. So this is basically the smallest item, which we're gonna only put in the end, and now we're gonna pop the end if the smaller item is greater than the end of the heap, because if it's greater, we can't keep that interval in our heap anymore, because this is how we are going to keep the maximum number of items in. We're trying to find out the maximum number of overlaps, and so heap, and we push the end out. We push the end in after we're done pushing all the other ends out, once our start can enter the heap. So max theater is going to be equal to max of max theater and length of heap. And we're going to return max theater. And submit. Okay, that was pretty good. I think this was a very good solution for this particular problem. It really uses the heap structure to handle the intervals, and I think this is a great way to solve these types of problems when you do see them. It is n log n, because the heap, well, it's not n log n, it's actually O of n, because we're going to go through each interval and insert them into the heap. Of course, sorting is n log n, and the pushing and popping of the heap is going to be a log n operation. No, is it log n? Yes. So anyways, it's O of n, and the space complexity is 1. But this is how we can manage interval type problems. I'm sure that there are many great ways of solving this problem. Please comment below if you know of them, and if you like this video, like it. If you want more, subscribe and check the link in the description below. Thank you very much, and have a good one.